scoop.
So there's these nice, fat, juicy, browny ones again. But then there's also this one that's got a white, shiny, pearlescent sort of growing tip. And then there's some others here which are much longer, sort of dark brown. So there's at least 3 different species, just that I can see by the eye. But sometimes when I've looked at them in the lab, and then you think like, oh, there's just all these brown ones, then you send them off for DNA analysis, they come back and it's like 6 different types, but they just all look very, very similar.
Yeah, but you can see there's some different ones in there.
You can see some of them, you can definitely see by eye.
Yeah.
But some of it's the shape, like this one is sort of coming out from the root and then very quickly going into like a V shape. And then some of them are just going along for a long time. Oh, and then some of them, oh yeah, here's another nice fluffy one I can see. And then, yeah, some of them are definitely a very different colour. So the colour, the shape, you know, are very defining.
And are mycorrhiza indicators for other stuff? You know how sometimes we can't measure the actual different biodiversity in the soil, but we could, something that is easily measurable is an indicator for something else?
Different mycorrhiza do different jobs.
Yeah.
We know that, although some of them will interchange and change what they do. They're sort of a little bit plastic like that, but some of them you will definitely, like plants, you will find in different habitats because they do different things.
Yeah.
But some of that knowledge we just don't have. So,
right.
You know, we know that some of them tend to access organic matter, some of them are better at accessing inorganic matter, so you'll find those in those different habitats and different depths where the soil changes. But we don't necessarily know exactly which ones do what. So they are indicators, but we don't necessarily have
We don't know
information.
what or how or...
Yeah,
okay,
yeah,
interesting.
Yeah.
What indicators are there in the soil? Because obviously you've got the soil type and the structure and the history and the geology we can tell quite a bit about, can't we? And we know what's above ground at the time that's helping build the top layer, presumably.
One of the big things is the amount of nitrogen in the soil. And that's one of the massive things that changes both in the soil biome, but also the plant biome.
Okay.
And that's mainly human inputs of nitrogen, and that's one of the massive changes that changes our habitat quite hugely.
Okay. And then so what about nitrogen fixing plants, so natural forms of nitrogen? Nitrogen would come from the soft matter that breaks down, right, in the forest?
So there would be a certain amount.
Yeah.
There's always a certain amount of carbon to nitrogen ratio.
Yes.
But we've tilted that
towards nitrogen rather than carbon.
Towards more nitrogen because of fertilizer, because of pollution giving out from cars, pollution given out from factories, it rains down.
Yeah.
So yeah, we've just tilted that all. So, and you can see that. I mean, if you study botany, you know which plants tend to be in those more nitrogen-rich habitats, and you can see it from the plants.
Yes.
And the same with the fungi.
And so, because when you're making compost, for example, I was taught anyway that you want a 1/3 carbon, 2/3 nitrogen balance. Is that something we could generalise about across, or with different
woodland soils? I don't know, to be honest. I don't know if we took an ancient woodland soil and said, this is the carbon to nitrogen ratio, this is what we want to aim for.
Is there an ideal?
Is there an ideal? There probably is. I don't know what it is.
Interesting though, isn't it? Yeah.
What was it before we started putting all this nitrogen into it?
And then, because you know, when we're gardening, we talk about, especially if we're starting to work a soil that may have been depleted, we use nitrogen fixing plants, right? So they're going to take a available nitrogen in the air through their processes and fix it in the soil, or are they pulling it up from the soil? When we say plants a nitrogen fixer,
they fix it in their nodules, in their roots, don't
they?
So
where are they getting the nitrogen from in the first place? From the air and putting it into the soil? Because you're improving your soil with nitrogen fixing plants.
Yes.
And availability of nitrogen, right, to other plants that come afterwards.
Yeah. I think they capture it from the air, do they?
Yeah. I don't know. I'm assuming. But these are all great questions. You know, these are the sorts of...
I feel like that's something I should know.
Yeah, but there's so much to know, isn't there? We've been talking about this all day.
Yeah, and that whole soil balance of carbon, nitrogen, carbon consuming, nitrogen consuming, rotting, that whole exchange, it's so complicated.
But that's something else for our 1 metre when we get to it later, is that, you know, there's so much to unpack, like incredible amounts.